Okay, let's look at section 2.1, factoring whole numbers, part 2. In the first part, we talked about divisibility rules and what factoring actually was. Now, in this section here, I told you I want to try to get it to where you can break numbers down, big numbers, it doesn't matter, with a very efficient way. And the way I like to do this is with what we call prime factorization. Now, we already know what factoring is, so this takes care of this piece of the word prime factorization. Now, prime, let's look at that. I'm going to reference page 87. Page 87, it's got a definition of what a prime number is. Let's look at that. A prime number is a whole number greater than 1 It's a whole number greater than 1 that has only 2 factors. And those 2 factors are 1 and itself. So a prime number is a whole number greater than 1 that has only 2 factors, 1 in itself. So I ask students, well, give me some prime numbers. So they'll say 3. Great. 3 is 1 times 3. I'll ask them, what about 4? They'll say no, because 4 has a factor of 2 in it. Correct. So it has something other than 1 in itself. Then they'll say 5, 1 and 5. I'll say 6. They'll say no, because 2 and 3 go into it. Good. Then I'll say, okay, what about 7? They'll say, yep, 7 works. And then at this point here, they'll say, oh, it's the odd numbers. Well, that's not necessarily the case, because notice I'm going to put down here, or over here, let's look at it, 9. Is 9 a prime number? No, because it has factors of 3 times 3. So it has something other than 1 in itself. So it's not the odd number. So we have to make sure that we don't make this mistake. A number is not prime because it's odd. That's not the case, because you can show many examples. 15, 3 and 5, etc. So 9 doesn't work. And then at this point, too, what I want to talk about real quick is kind of throw a story in here. I was watching Are You Smarter Than a Fifth Grader one night with my daughter years ago, and the question that would have doubled the man from 500,000 to 1,000,000 was, name the only prime number that's even. And he decided not to. He took us 500,000, and I was crying at the sink because I thought, man, it's 2. 2 is a prime number because it has 1 and 2. The rest of the prime numbers are all odd, but it's not every odd. Just like we said here, it's not every odd, because every other even number has 2 as a factor. That goes back to our divisibility rules. So 9 doesn't work, 11 does, 13, 15 doesn't, 17, 19, remember 21 doesn't because of 3 and 7, 23, and I won't keep going here, but you get the idea. You can look up the prime numbers. You can go on the internet right now and pull up a list and get prime numbers almost to infinity. And I do recommend you keep that in mind as we work through these. But this is going to help us. Now notice we have the prime numbers and we know what factoring is. So what we're going to do is we're going to take numbers and we're going to break them down using prime factorization from now on. So this is a skill that I really want everyone to have. Now this is backed up by a rule. It's listed as rule number 4 on page 88. This rule is very important. It's called Rule 4 because the other 3 rules in this book so far have been the divisibility rules for 2, 3, and 5. Those were the first 3. So Rule 4 just happens that they called it 4. Rule 4 says that every whole number greater than 1 is either a prime number or, and this is important, can be written as a product of primes. So just take a second to think about that. Every whole number greater than 1 is either a prime number itself or any other number can be written as a product of prime. So that covers every number. So that means we can break down every number to prime numbers or its prime itself. So that's very important with us moving forward, breaking numbers down. Okay, let's look at a couple of examples. Let's look at, and just in case if you want to reference it in the book, this is example 6 on page 88 in the book, and I occasionally make up my own. Sometimes I take them out of the book. We want to completely factor the number 91. Now again, I asked students in the past, how would you break this number down? And they start looking at the ceiling, or they say, I think it's prime. It looks prime. And I'll say, well, just like we talked about with the pizza example, something intuitive might not be that way. That's why we apply math. So what we're going to do is I want you guys to start breaking numbers down based on prime factorization. So here's what I'm going to do. And I'm going to list out just a few. 2, 3, 5, 7, 11. And I'll stop there for right now just to kind of get us going. I want you guys to start breaking numbers down using prime factorization. So let's look at this number. And I always want you to start with 2. Always start here. Start with the smallest. What happens sometimes is people want to break this number down by jumping to some huge number. And I liken it to when I'm teaching somebody how to swim. I don't dump you in the deep end. We always start and put our foot in the shallow end and work from there. So I want you to always start with 2. And think about the power of cutting something in half. You know, if you had a debt of $10,000 and you could cut it in half, that's a huge chunk. You dropped it from 10 to 5. So if you start there, you're going to make some real progress. You know, if I was going to go cut down every tree in my yard, I'm going to start with 1 and work there. I'm not going to try to cut them all down at the same time. So the same thing here. Let's look at 2. Based on our divisibility rule, does 2 go into 91? The answer is no, because the 1's place is 1, and that's not an even. So 2, we put it on the shelf technically. It's done. We can't use it to break this number down. Let's look at 3. Well, our rule for 3 is we would look at 9 plus 1. That makes 10. That's not divisible by 3, so 3's out. What about 5? Does 5 go into it? No, look here. This 1's digit is not 0 or 5, so 5's out. Now, we didn't have any divisibility rules above 5. We're just going to have to try them from there. Well, let's try 7. Okay? So 7, just try it. 7 goes into 9 once. Subtract, get 2, drop the 1. 7 goes into 21, 3, 21. 7 does go into 91. So we know that if we break this number down, 7 goes into it. Now, I want you to start taking a new approach here. I want you to start breaking numbers down like this. I want you to use this notation. Okay? 7, and then I want you to do what's called the scratch method. It's going to make it much easier because you're going to work with 1 at a time. 7 goes into 9 1 time. Okay? So you put your 1 here. And then whatever's left over, I want you to scratch this and write whatever was left. So 9 and 7's difference is 2, so you put a 2 here. Then 7 goes into 21 3 times. And now I want you to look at this. If you do this breakdown and you get to a prime number, which 13 is prime, then I want you to stop. You can stop because it has to be, based on Rule 4, a product of primes or a prime number itself. So what we have here is 91 factored out prime factorization is 7 times 13. This is the breakdown of 91. Now remember, originally I have students that say that was prime. We can prove here that it's not. And our new method, the scratch method here, and using this different type of line, if you will, it's going to help you. As we go through the example, you'll see, and I will need you to open your mind on this section. This is a pretty important section. All right, let's look at example 7. Let's look at another number, 52. And let's go through our process again. All right, I'm going to list out a couple. All right, does 2 go into this number? Always start with 2. Start with the smallest. Don't try to jump to some huge number. Start with 2. 2 does go into this number because this is an even digit. So we're going to put our 2, and again, let's see our scratch method. 2 goes into 5 2 times, which is 4, which means we have 1 left over. So scratch that out and put 1. 2 goes into 12 6 times. So 52 is 2 times 26. Now, the next thing is we drop to the next level. Let's see, because 26 isn't prime. If you list these out, you'll see 26 is not prime. One reason you can tell is it's even. So then what we do is we go and we try 2 again. You continue to use 2 until you've exhausted it. So 2 does go into this number, so 2 goes into itself once. Scratch it, there's nothing left over. I put a 0 just to show that I did it. 2 goes into 6 3 times. Notice we've reached a prime number, we can stop. So now what we have is 52 prime factored as 2 times 2 times 13. So we've broken this number down into prime factors. You got to keep that in mind, because some students will say, well, I know 26 goes into it. Correct, it does. But what we have here is prime factorization. We're only breaking it down into prime factors. Remember, all numbers are either prime themselves or can be broken down into primes. Okay, let's look at another one. Let's look at 53. This is example 8, and this is actually on page 90. And example 7 was on page 89, if that helps you out as well. Okay, so example 8, we're going to look at the number 53. Okay, let's bring up our primes again just to kind of see what we're working with. And again, you might have to go beyond this. I recommend, I'm going to show you a rule here in a few minutes that'll help you out. It will give you a good stopping point. All right, let's try 2. Does 2 go into 53? It does not, because this is 3 and not an even number. Does 3? Well, 5 plus 3 is 8, which is not divisible by 3. And I'm sorry, I wrote an extra 3 here. So does 5? No. 5 doesn't, because it's in 0 or 5. We'll try 7. 7 goes into 53. Let's say we would say 7 times 49. Do our subtraction here. We get 4. There's a remainder. No. 7 goes into 53. 8. That's 56. That's too big. So 7 does not go into 53 evenly. Now, the question I have from a lot of students, and this is a great question, they say, look, I'm getting tired. When I just don't want to keep going forever. And that is a great point. And what that leads us to is Rule 5, which is going to be pretty important. So let me talk about Rule 5 here. And this is on page 91. This is Rule 5. This is a very important rule. This gives you the stopping point that you've been missing probably for a long time. Rule 5 says to completely factor a whole number, to completely factor a whole number, it is only necessary to check for divisibility, by those prime numbers that multiplied by themselves equal a number less than or equal to the given whole number. Now, just let's take a second and ingest that. To completely factor a whole number, it is only necessary to check for divisibility by those prime numbers that multiplied by themselves equal a number less than or equal to the given whole number. So what that means is, and we'll show you with 53, is we tried 7, right? Well, 7 times 7 is 49. So what that tells me is that I had to try 7, because when 7 multiplied by itself is a number, 49, which is equal, less than or equal to that given whole number we're looking at. See, 53, 49 is less than or equal to 53, so I have to try 7. Now, here's the wonderful part. Just like you said earlier, students always bring up the fact that where's the stopping point? Well, look, do we have to try 11? Let's apply Rule 5. 11 times 11 is 121. That number is not less than 53 or equal to 53. So what that tells me is I don't even have to try 11. I don't have to go any farther. I am completely done. So when you get to this point and you don't have to try the next prime number, what that tells you is that this number you're looking at has to be prime. It has no factors that are prime at all. So this is a great rule. I love this rule. It helps us come to a stopping point. As you try this, as you start breaking more numbers down, I want you to keep that in mind, that this is a very, very powerful rule for us. If the number that you're going to try times itself is larger than the number that you're looking at, then you don't even have to try it. We did not have to try 11 because 11 times 11 was bigger than 53. So we know that 53 has to be prime, and we're done. Because numbers are either prime or they're made up of a product of primes, as we can see here. Okay, let's look at one more example in this section. This is example 10. And this one's on page 92. And this is a big number. Let's look at 1,650. This might be something in the past your students just say, hey, you know what, teacher, do I even have to do this one? What can I make on this test if I don't do this one? Well, those days are over now. Now that you have this section and you have these rules and prime factorization, let's again look at our prime numbers. I'm going to stop here for now. Let's break it down. Let's start with 2 like we always do. Okay, 2. 2 goes into 16 8 times. There's nothing left over, so I'm going to put a little 0 there. 2 goes into 5 2 times, that's 4, so that means there's 1 left over, so I can scratch that. And 2 goes into 10 5. Notice we cut that number in half. That's pretty powerful. We will try 2 again on the next level, but notice this has a 5 in the ones place, so 2 doesn't go into it. So we can move on. 2 doesn't work. Now here's a little caveat. Don't jump to 5. Because what happens is sometimes you jump to these big numbers and the other little ones will show back up later and it confuses everybody. See, now once 2's on the shelf, 2 will never come back as a factor once you do it this way. Let's try 3. Well, let's do 8 plus 2 plus 5. Okay? That's 8 plus 2 is 10 plus 5 is 15. 3 has to go into this number. And again, if you didn't know that, just do 1 plus 5 now and that's 6. 3 goes into 6. So 3 has to go into this number. So let's do it. 3 goes into 8 2 times. Scratch it, 2 left over. 3 goes into 22 7 times. Scratch it, 1 left over. 3 goes into 15 5 times. Perfect. Now, we tried 3, but we need to try it again because we have to exhaust it. Okay, so let's do 2 plus 7 plus 5 and see what we get there. 2 plus 7 is 9, plus 5 is 14. We know that 3 doesn't go, so 3 is exhausted. Now let's go to 5. Does 5 go into 275? Yes, because the ones place is 0 or 5, so we know 5 has to go into it. 5 goes into 27 5 times. Scratch it. That's 25, gives us 2 left over. 5 goes into 25 5 times, so we have 55. All right, now we've used 5, excuse me. Then we need to exhaust it, so try it again. Does 5 go into 55? Yes, because this is a 5 here at the end. So 5 goes into itself once, scratch it, 0. 5 goes into itself once. 11. Once you've reached a prime number, 11's prime, you can stop. You've broken the number down as far as it'll go. So the number 1,650 broken down using prime factorization is 2 times 3 times 5 times 5 times 11. We were able to take this big number and completely break it down using prime factorization.